Okay, the last thing that I want to talk to you about today is Polya's 4 steps, and this is from your textbook, right? This is page 2 of your textbook, which, right, looks like this. Exploring Mathematics, right? Anyway, has a picture of a cute little girl in the front. And so the first chapter, which, by the way, part of your homework tonight is to read through the first chapter. It's not long. You read like the first 6 pages or something, and then everything else is exercises. But so you're going to read about Polya's 4 steps in this first chapter. But I did want to briefly mention them for a couple of reasons. Number one, because this is what I'm going to be looking for when I look at homework and tests and things like that. I'm going to be looking to make sure that you have evidence of these things. Now, that's not to say that every single problem that you work out that you need to write out Polya's 4 steps, because you don't. I might have certain problems, like on the homework tonight, I'm going to have a couple of problems where I ask you specifically to state Polya's 4 steps. But generally speaking, I don't expect you to actually write down step 1, blah, 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 step 2, blah, blah, blah. But you should have some evidence that you did all of these thinkings. Sorry, I'm going to pause this because the train's coming. Okay, I'm back. I live right by a railroad track, and anyway, when the train comes by, it's loud. It doesn't come by very often, though, at most like once a day. But anyway, so these are the steps, right? These are Polya's 4 steps. So let's talk about each one of these things. Well, I was saying, on some assignments, I may ask you specifically to actually write out all 4 steps, but for the most part, you don't have to do that, right? Like, you don't actually have to write out all 4 steps in detail. But when I ask you to solve some kind of problem, there should be evidence that you understand the problem, right? And that you've thought of a good plan, right? That you've carried out that plan, and then there should also be some evidence that you're looking back. So you'll read more about each of these in the reading tonight, but I just want to briefly say a couple things about them. So step 1 is understanding the problem. That means that not only do you need to read the problem, but you need to read it and reread it until you're sure that you understand it. Sometimes it's a circular thing, right? Sometimes you sit down to try to understand the problem, and then you go to formulate a plan to solve it, and in trying to formulate a plan to solve it, you realize that you didn't really understand what the problem was asking. And so then you need to go back and you need to think about it some more. Some things that you can do to help you understand a problem is to write down some of the key information that's given. You can draw a picture. You can start making a chart, right? Something like this to collect the information. But make sure that you have a good, solid understanding of the problem before you go about trying to solve it. Okay. Oftentimes, when dealing with problem solving, the biggest mistake that students make is they try to jump straight to like step 3. It's like if you're in algebra class and you're trying to solve some kind of application problem, the biggest mistake I think students make is that they immediately try to write down an equation before they even understand what's going on. Before they even understand what x is supposed to represent, right? They just start to try to write down an equation. So take the time up front to really understand what's going on, and you'll find that everything else goes a little bit easier. So understand the problem. Step 2 is to devise a plan. And to devise a plan, there's actually a list of suggestions that the book gives you. I think it's on the next page. Yeah. So it gives you 10 suggestions of things that you could try, some problem-solving strategies. So you can try guess and check, you can try drawing a picture, you can try working backwards, right? You can try writing down an equation, you can try solving a simpler problem. This is an important one, and as we go through these next few days when we're going through the Chapter 1 material, but by the way, I've gotten ahead of myself and I should have mentioned, Chapter 1 is all about problem solving, right? So as we go through the Chapter 1 material, I hope to give you some examples of each of these different strategies. But solving a simpler problem is really good. I'll give you an example of that right now. So let's say that you were asked a question like, if a car gets, 13 2/3 miles per gallon, right? How far can it, well, how would we say this? So a car gets 13 2/3 miles per gallon. How far can it drive on 5 3/4 gallons of gas, right? So a car gets 13 2/3 miles per gallon. How far can it drive on 5 3/4 gallons of gas? Now, for a lot of people, that's really kind of difficult to think about. And what's difficult about it is the fractions in the problem, right? They're thinking 13 2/3, 5 3/4, and suddenly they like lose all of their mathematical intuition, and they're like, should I add those numbers? Should I multiply them? Should I do something else? Should I divide them, right? Do I need to double one of them for some reason? I mean, this is what people kind of go through. But if you make it simpler, if you solve a simpler problem, if you say, well, instead of the car getting 13 2/3 miles per gallon, what if it gets 5 miles per gallon? And instead of you using 5 3/4 gallons of gas, well, what if it uses 2 gallons of gas, right? So the car goes 5 miles per gallon, and you have 2 gallons of gas. How far is the car going to go? Well, it's going to go 10 miles, right? And what did you do? You multiplied the numbers. So if you're multiplying down here, it stands to reason that you would multiply these numbers as well. So sometimes solving a simpler problem is good. Anyway, I didn't mean to spend a whole bunch of time talking about just number 10, but I wanted to give you an example, right? All of these things are good strategies, right, that you can employ when you're trying to do some kind of problem solving. So that should help you with step 2. Okay, so step 2, devise a plan. So that should help you with step 2 there. Step 3 then is to carry out the plan. That's the easiest part of the process. Once you understand the problem really well, and then you've devised a plan to solve it, carrying out the plan is a piece of cake. And then step 4 is to look back. When we look back, there's a number of things that we do. So one of the things that you should do when you're looking back is you should pause to ask yourself, does my answer make sense in the context of the problem, right? Is it reasonable? Going back to the miles per gallon situation, it was 13 2/3 miles per gallon, and you had 5 3/4 gallons of gasoline. How far does the car go? Well, if you had gotten something like 0.72 miles, that should automatically ring some bells. Like a bell should be ringing in your mind, like an alarm should be going off. That something went wrong there, right? Because somehow you got less than 1 mile, even though the car goes 13 2/3 miles per gallon. So on 1 gallon of gas, it's going to go 13 2/3 miles, right? And you had more than 1 gallon of gas available to you. So there's no way you should be going less than 1 mile on that amount of gasoline. Or if you got like 4 million, right? Then again, obviously something went wrong, right? So you should ask yourself, does my answer make sense within the context of the problem? Another pretty fundamental question to ask yourself is, did I answer the question? A lot of times you're solving a problem and you set up some kind of equation with x in it, you solve for x, but then x isn't the answer. X is just a step in the right direction. So it's always important to ask yourself, did I answer the question here? Right? So ask yourself, first of all, did I answer the question? Second of all, is my answer reasonable? Is it reasonable? Another thing that you can do when you look back is you can try to check your answer somehow. This is really easy to do if you're solving some kind of algebra problem, right? Because you could just plug your answer back into the original equation and make sure that it makes sense, right? See if it gives you the correct answer. It's a little more difficult to do when you're doing kind of a problem-solving type of thing, but one way that you could check your work would be to try to solve it in a different way and see if you come up with the same answer. Or use your answer to work backwards, right? To see if you end up with whatever your initial sort of parameters were. Anyway, that's kind of vague, I guess. It's hard to give you an example without looking at something concrete. But like I said, we'll do this together, and the book, as you read through it, it'll give you a concrete example of each of these 4 steps. But looking back is an important one for sure. I think that's all I have to say about Polya's 4 steps for now.
So again, read through this chapter. You'll understand Polya's 4 steps a little bit better. And yeah, so that's it for now.